Everyone. I feel like I'm with the most dedicated people here. Thank you for being here before dinner. And I am excited to talk about our most recent research in the subject. As I said in the morning, I have been coming to ISMB since I was a master's student. So it's really great to see how ISMB grew and I'm part of this growth. So thanks again. I am Hande McGinty, and I am currently an assistant professor at Kansas State University. Before joining K-State, I was at Ohio working with the USDA, and before that, I was working for Collaborative Drug Discovery, who's one of the sponsors of this. Yay! All right. So today we're going to talk a little bit about flavonoids, but I'm really excited that I heard so many talks today that really reminded us how important quality is and how much we really need to keep the domain experts in the loop as we advance more and more on these automated methodologies that we're working on. So just a quick information for those of us who are not domain experts. Flavonoids are a structurally diverse set of chemicals that are chemical composition components of plant-based foods, and they're actually really undervalued. They have a variety of great benefits. They help lower stress, inflammation, and oxidative stress, and they actually have very great therapeutic effects on cancer too. And literature, when you look at the papers, when you search for papers, you see a number of papers out there that are really looking at this benefit, and they really talk about the different benefits of different flavonoids, different foods, and therapeutic effects on cancer and cancer-related studies. But there is really no systematic way of looking at this. So we followed our systematic approach called NARM because I couldn't come up with a better acronym right after PhD. The first time I was presenting this, so Matthew Lang, some of you know him, I know, comes to my poster and he goes, "Why didn't you name it Karma?" And I'm like, well, that's an exponentially better name, but it's too late now. And I tried to recover from it in a number of presentations and publications, but we're stuck with it. But not to worry, we're rebranding it as Olive. It's coming up. So anyway, NARM is a really systematic way of looking at building ontologies, as Michael was talking about how it's not about how big these things are, but it's really building it with purpose, really keeping in mind the end product and applications that these ontologies will be used for, and really kind of keeping that in mind as you go along with the building process of these knowledge graphs. And with this methodology, we really tried to classify the flavonoids. We didn't classify, we really formalized the classification. And we ontologized USDA's database that looked at some survey data. USDA does regular surveys on what Americans eat. And this was flavonoid content information for some of those foods that were in that survey data in 2007 and 2008. And we really generated some axioms to connect these flavonoids to their foods and their diseases that the literature told us. So to look at that, we automated some literature mining, and based on that, we created, like I mentioned, the classifications of the flavonoids and the foods and the beverages in the data set. And we pulled the cancer names and really created these connections. And in addition to the automated version of the literature creation and annotation, retrieval annotation, we actually, too, like a lot of people in this session today, manually went through the pain of curating some of this data that we pulled, just so we have quality data that we think is worthwhile. And then, as part of the methodology, we went through what is already existing in the vocabularies, because we have very little interest in creating new vocabulary, especially if it's already been created. In our methodology, there's very little value added in reinventing the wheel. So we mapped a lot of the food names to food on, and disease names to disease ontology, and nutrition composition components named to CDNO. And by the way, we also realized that there's also no systematic way of looking at it. And there's a poster at ICBO for those of you who are adventurous enough to go to Netherlands after this. You can maybe see that in person, but we are actually looking into how we can make that better too. Okay, so even though we have no interest in recreating some existing vocabularies or naming things, we are very interested in how we model these things, primarily because we really want to make sure that these things are modeled in a way that they can be reused easily by the algorithms, by the applications, and various use cases that you might have with it. During my time at the USDA, I spent a lot of time with the Food Data Central data, which looks at food and chemical composition components data. And for that, we created this modeling of food. I'm noticing that it's not really very readable. I'm sorry about that. But it's really just showing that the food and its chemical composition components are mentioned. And in addition to that modeling, we also attach the disease connections to those chemical composition components in this research. So like many of you mentioned today, maybe not so rightfully, we trusted the literature, and we also trusted USDA's curators who created this data set in the beginning. So as far as knowledge acquisition validation goes, we just assumed that everybody did their due diligence, and we trusted everything they put out there is correct. But when we collected all these big chunks of data, we also believe that keeping it in spreadsheets and reusing it from spreadsheets to create ontologies can be tedious at times. So we really love creating a database backend. For that, we use Neo4j, and we put all of this data into Neo4j database so that we can kind of reuse it in different formats and in different sections for different projects to build concordant ontologies. So once we had this data set annotated and created and put into a database nicely, we decided not only to use our automation to create these OWL files, but really experiment with the large language models to see how can they improve our curated data sets and add more information to this disease flavonoid contents. Because one of the things we realized was actually, very much to your point this morning, we were really poor at asking the right questions because we are computer scientists. And we don't really know what we should be asking. So we said, okay, we know we should do what we know. So let's do the experiments in large language models and see how they work with the different data sets that we have and how they work when we ask them questions in different ways and so on and so forth. So in the back end, we have, and we also created a not so beautiful looking perhaps, but functional user interface so that we can really play with the knowledge graphs. We can load an existing graph, we can ask it questions, we can use different large language models, and we can really see how they perform differently. And ask the large language models to build a prompt, return it, and then based on the response, create the data, create the knowledge graph and kind of give it back to the user. And this is how our user interface looks like right now. As I promised, we rebranded it. It's Olive now. It's way more catchy than NARM. And like you see here, you can load an existing graph, or you can create one from scratch, or you can extend what's going on in your graph and see how it performs. And I'm happy to show you if you want to play together tomorrow with this tool. But right now, when we load our graph and ask the LLMs to kind of add on to it, we get a graph more or less like the one that's on the right-hand side. So I think the bigger question for us, at least, as we kind of ask different large language models the same prompts, and as we ask different prompts to see what kind of results are changing, as we change the data in the database, and as we kind of added modules to our knowledge graph, we have seen that the results really were different, which brought us the question of, okay, how do we really validate this? What's going on? How can we really validate this? In our paper, the validation case was made, and a number of reviewers said, well, you should be using reasoners. But this is not so much of a reasoning question, because the relationships are not logically inconsistent. They are there and they're at it, and there is no logical inconsistency that we came across. I'm sure if we run enough tests, there may be cases here and there, but it's more of what's really happening, and are the results really worthwhile to add on to, or to create hypotheses, or to go on and do actual wet lab testing and see how the results compare to our case. So another tool that we used for ontology validation was OOPS. And similarly, there are missing annotations because the new nodes are not created equally to our well-created ontology nodes. And there are some missing relationships here and there. If it's a new thing, then there is no ontology declaration and things like that. So surely some things are not created equal, but it's, again, not so much can we create a new knowledge graph node, or can we create another module, or can we extend the knowledge graph using large language models? It's not a question of that. It's more of a question of how well are these new products, how these extensions to the existing knowledge graphs are being built. And I think that needs systematic exploration. To our knowledge, there is none currently, and we're working on that in our lab. And I'm happy to talk to you more about it if you have ideas and if you have ways that you're thinking about this. And we want to talk to you, or we want to collaborate with you if you're also working on that. A couple of acknowledgements. A lot of projects went into this, but this was particularly funded by the Cambridge NIH grant that's based in Kansas. I thank to all my collaborators who helped me to be here today. And this is my lab, and these are my students who also helped write this paper. Thank you very much.
Had you tried any of the loops of doing a checking for your checking for compliance with your ontology, and then kicking it back if it was non-compliant, at getting the LLMs to try again? Did you try that? And if so, how well did it work?
We did. We did try that. We have some collaborators who helped us kind of go over it and look at it. And one of the problems is, as we noticed, sometimes the large language models like to shortcut what's in the knowledge graph, and they just kind of do what they already know, and they don't really listen to what you kind of try to correct them. And they're like, no. I have more data that's telling me this than your little data set that you just fed me. And we're actively, as I said, we're actively working on how to kind of fine tune that to see if we can improve that. But yeah, it's a work in progress. Yeah.
So thank you very much. I have a question about LLMs as well.
Yeah.
So in my mind, an ontology is essentially a standard. It has statements that are necessarily true. Now, once you build an ontology or use an LLM to build an ontology, you don't have this guarantee anymore.
Mhm.
And it's my feeling that unless there's some fundamental advance in LLMs and how they're built and how they operate, I'm not sure if this is not two entirely incompatible things. We get something that very probably, but not certainly is right. And we want to build a standard based on which maybe thousands. I mean, imagine gene ontology. If a gene ontology was built by an LLM and we rely on this for medical decisions or for medical research, for clinical research, we rely on it for designing experiments which are millions of dollars, cost millions of dollars. It would be, I'm not sure, but my feeling is that these are two entirely incompatible things. And maybe I'm not sure what your feelings are about this.
I think I understand your point. To play the devil's advocate, perhaps in this case, anyone who's been through the process of building an ontology knows that it takes forever, right, to agree on a single term. And if you have been through that, then you can kind of see, and depending on the domain, depending on the use case, even having a starting point in starting the discussion in the right direction, I think gives you a good head start. I'm not saying that they can be, especially now, can be used as is, and that was exactly the point I was trying to make. Is like anything that you create using large language models can be used as is. But in the process of building an ontology, can we use this to our advantage, to gain advantage? Yes. Let's do this.
No,
No,
yes.
no, you're
I
going.
have a follow-up question
Yes.
to this. If you look at the previous talk,
Uh-huh.
the previous talk tried to establish an ontology because the terminology in this field was fundamentally incoherent.
Very good
And
point.
gene ontology was built at a time when we did not have any way to start.
Right.
Now, in many fields, this is where an ontology matters the most, is where we have all these inconsistencies,
Right.
or where we have nothing, where we just have large amounts of free text. And in these cases, and I would like to see this evaluated at some point, but in these cases,
Sorry, that was my timer.
so in these cases, would you expect an LLM to be of any help, even as a starting point?
So that's another great point. But here is the thing. Right now, ontology building is most of the time performed by a handful of domain experts, right? Where is the bias in that? Do we ever evaluate that? Because a lot of the ontologies, and I have been in this field for more than 2 decades now, and I'm part of the OBO Foundry operations committee. Like I'm there. I'm really happy, hoping to help the community, and really, I know how valuable this work is. But at the end of the day, we are a handful of experts or domain experts. I'm not even one, and I'm attending these goals. So who is really creating these vocabularies that we take as ground truth? I mean, it's the same. I don't think it's two completely different problems. It is one big problem. Hey, I don't have tenure, guys. Don't make me tell these things. But So I think it is a problem. But I think that as I was really happy to hear all the talks today, just to see how almost every single person kind of touched on this quality problem. Because as we are automating more and more things, we're realizing, wait, what's happening here? So, yeah.
So then I have a question following up on that. Do you have any suggestions of how we should be evaluating these, whether that's for an LLM or a human curated ontology?
So I think my biggest suggestion is really keep the domain expert in the loop. So, really make sure that we are not, relying on full automation, dare I say, just yet. But, I think keeping the domain expert in the loop is very crucial to a lot of these processes.
Okay, I'm going to be really annoying right now.
Go for it.
Earlier, you said that one of the key issues in drawing out the process of building the ontology was obtaining agreement.
Mhm.
You use the word agreement,
Mhm.
and that means there's a negotiation process
There
happening
is.
between multiple domain experts. Now, in a model, I mean, and just then you said, okay, we're going to have, an expert working with the LLM to kind of do this process, and the expert singular will be.
so appreciate you nitpicking
So
here.
sorry, I'm a linguist.
True ontologist.
Exactly. So I mean, I think it's an important point though, because how can we possibly expect the agreement between an automated text extruding machine and a human to be any higher than between two humans or
Yeah.
three humans?
And by the way, don't miss Alex's talk tomorrow, because as you see the ontologies being used in the community, you will see that no matter how many experts you put on it, there are missing terms, there are terms that are wrong, there are terms that need updating. And it's not even about experts all the time. It's also because times are changing, things change, methods change, technologies change. So to accommodate those changes, there's really not a systematic way to handle this. And that itself is another problem. And the true test, and again, in this methodology, just so it's circular, is this is a never-ending process, right? There will always be something that's coming up that may be needing change and all of that. So it's not really an expert, a set of experts, 5 experts, 500 experts. It's about really making sure to keep an eye on the quality bit. So it's not a numbers game. It's not like
No,
500
I
would
agree
be
it's
better.
not a numbers game, but the question is, what is quality? How do you decide what is, true?
And that's another great question. I think that's a really great point, because I've read a lot of different things that claim they're creating gold standards in ontology evaluation. I'm like, there's not a gold standard in ontology creation. So, where is the gold standard? And that's not for me to decide. I think that's a good community discussion.
Yeah, well, it comes down to community consensus, I guess. But yeah.
Of course, but the community also changes, right? I mean, Dr. Bradshaw just got a PhD. Now he's part of the community too. So now, he wasn't here 20 years ago, but now he is. So now everybody, this is again, the ongoing process cannot be ignored. It's an agile process.
Thanks.
Yeah.